Yes. Good morning and welcome everyone. I think this is lecture number 14 and probably this is, not probably, definitely this is the last lecture on modern physics. And we'll be winding off modern physics today in this class. Now you must understand that we are expecting around 4 or 5 questions from this portion that we have discussed. And all of those questions would be pretty straightforward, as you would have seen. So if you have paid attention in the class, you should be able to crack 4 or 5 of those questions out of 45 in your quota in physics. The last thing that remains today is what? What are we supposed to do? Okay, you cannot speak. I mean, you can speak, but I can't hear you. One and the same thing. I think it's logic gates. So we will be starting with logic gates and we would be winding with logic gates today itself. But it is not that big a topic that will take so much of time, and I guess most of you would be having some idea about logic gates. Yes or no? Again, you can't respond, so I would have to make my own assumptions that you probably know something about logic gates, and that something is good enough because there is nothing new in this. There is nothing that you have to study differently. It's the same thing that you would have known. So without much ado, let us move on and see what is logic gates. Again, what we are doing here has been taken from your sheet that I have given you. It's already there with you. Okay, logic gates. What is a logic gate? Well, a logic gate is a gate, so it will have an input, inlet, and outlet. You will get in, you will get out. Gates are used for getting in and getting out. So gates refer to inlet and outlet, input and output. Logic, that means this gate will operate on some sort of logic. I hope we understand this. So logic gates will give you input and output, inlet and outlet based on some logic, and that is what a logic gate is all about. It's a digital circuit. Oops. When we start, something happens. It's a digital circuit which based on certain logic between the input and the output. There is some logic. There is something that relates the input and output. All these things that I'm going to tell you, this is just for your information. Logic gates are built using the PN junction diode, transistors and all that. That is why it comes in modern physics. Each logic gate has a symbol. The operation of a logic gate is indicated in a table which is known as the truth table. Have you heard about truth table? Yes, you heard about truth table?
Yes, sir.
Okay, voice is there. Good. So, it has a truth table and we'll come to that. What is that truth table? That truth table tells us the truth. It also tells us what will happen. Good. What will happen if you give one thing in the input? What will be the output that you are going to get? So that is known as the truth table. It contains all possible combination of inputs and their corresponding outputs. So whatever be your input, you will put it there. And whatever is your output, you will also put it there. That table is known as truth table. Now a logic gate is represented by Boolean algebra. Now what is this Boolean algebra? We will understand this Boolean algebra. Don't worry about that. So there are 2 or 3 things that we have to understand in this chapter. A, what is a logic gate? Input, output. 2, what is the truth table of the logic gate? Nothing. It will have all inputs and their results. 3, what is Boolean algebra? So these are the 3 points that we are going to discuss, and I hope that all of us are ready. Shall we move on?
Yes, sir.
Yes, sir. So the first and the most simplest and the first one, and I've always done this first. I don't know why, because It just looks simple and it is very easy to understand. All of them are easy to understand. There is no complication behind it, no complicated maths. And that is why we expect a question from logic gates in your exam, because it does not consist of any typical math, no multiplication, no division, simple addition. Okay, so what is this first gate? The first gate is known as the OR gate. Have you heard about this term, OR gate?
Yes, sir.
Yes, sir? No, sir? Tell me, sir. Have you heard about OR gate?
Two input and one output in OR gate.
Most of the gates have two input. Some gates have one input, one output. Okay. Do you know the symbol of the OR gate? This is the symbol of the OR gate. Do you know this symbol? You have heard about this symbol, OR gate? You've seen this symbol? Okay.
Yes,
A is the input, one of the input, and B is the other input. A and B are the two inputs that you can see. And the output is A plus B. Do we see this? Or shall
Yes,
I make
sir.
it more big? Okay. Output is single. Inputs are two. One input is A, one input is B, and the output is A plus B. Now, whenever we talk about logic gates, we talk about two numbers. One number is 0 and the other number is 1. It's binary expression. Either it is 0 or it is 1. For example, if I ask you a question, are you hungry? So the answer is yes or no.
Yes.
If it is, sir, I might be hungry, I might not be hungry, but that's a ulta answer. Answer is either yes or no. So yes means on, light is on, yes. So yes or on stands for 1 and off or no stands for 0. So that is what we call binary or binary code. Do we understand this?
Yes, sir.
A switch only has two positions. On-off switch only has two positions. Either it is on, light comes, or it is off, light goes. You can't put it in between because it does not work. 0 and 1. So 0 and 1 are the two things that we have to deal with. And in this logic gates, this table that we have drawn here is known as the truth table. Do we understand this?
Yes, sir.
This truth table has all the possible values of A and all the possible values of B, which are the input. And then it tells you all the possible values of Y, which is the output. So whatever you put in the input, what the output that you will get, everything is shown in this table, and this gentleman table is known as
Truth table.
the truth table. Okay. And when we talk about the OR gate, the Boolean expression for this OR gate is the output Y will be equal to A plus B. Now, how do I find A plus B? This A plus B is as good as maths, but there is a simple twist over there. If both are 0, 0 plus 0 is always 0, correct?
Yes, sir.
So 0, when we have 0 in all the inputs, we will get 0 in the output. So if all the inputs are off, the output is also off. Do we understand this?
Yes, sir.
Okay. Now, if I make one input 0 and the other output 1, so 0 plus 1 will also be equal to 1. This is simple maths. Yes or no?
Yes, sir.
So if any input is on, the result is on. If the other input is on, the result is also on. Yes or no?
Yes, sir.
Okay. Now, when both of the inputs are on, so 1 plus 1 does not become 2 here, because there is no 2 here, only 0, 1 and 1. So if both of them are on, the answer is still on. Do we understand this?
Understood, sir.
And that is the OR gate. OR gate will give you the output. So basically OR gate mein what is going to happen? If any one of the inputs is on, the result is always on. The only way you can get an off result, 0 result, is when both the inputs are off. Do we understand this?
Yes, sir.
And that is the entire logic of the OR gate. It is A plus B If both of them are off, then only you get off. If any one of them is on, you will always get a on result. And that is what you have to draw and write. You have to draw the Boolean expression y is equal to a plus b. You have to understand the symbol of the OR gate, and you have to understand the truth table. And I'll give you a minute to do this. If you have any expression, if you have any doubt, please let me know. 1 minute. Now everyone will write. Any doubt, please ask me. Let your doubt be settled by me rather than you discussing it, because you might discuss some movie or some game which may not help right now. Don't get confused in the symbols. OR gate and AND gate may look very similar, but the symbols are different. AND gate and NAND gate, OR gate and NOR gate, they just have a very small difference, and you have to understand that difference. Have we done this?
Done, sir.
Done, sir. Then, sir, the next gate, sir, which is as simple as the other gate, and this gate is known as the AND gate. This gate is known as the AND gate. Again, it has two inputs, A and B, and it has one output, Y. And the symbol, it might look similar to the OR gate symbol, but it is different. This is the AND gate. And what is the Boolean expression? The output Y is A dot B, or A multiplied by B. Do we understand
Yes,
this?
sir. Understood, sir.
Yes, sir. Then 0 multiplied by 0 is 0. If both are off, it is off. 0 multiplied by 1 is 0. If any one of them is off, it is off. The other one is off, it is off. It only gets on in one case, when both of them are on. Do we understand this?
Understood, sir.
Understood, sir? So these are the three things that you must remember about this. One is the truth table, other is the Boolean expression, and the third one is this symbol. And you will only get a minute to write it. Do you understand the difference between OR gate and AND gate?
Yes, sir. In OR gate, y is equal to a plus b. Here, a into b.
Yes. And in OR gate, if I talk in simple terms, if any one of them is on, the result is always on. Here, the result will be on when both of them are on. Do we understand this? OR means either or. One of them is on, you are on. AND means both of them should be on to get the result on. That is how I understand it. And I'll give you a minute, 1 minute, single minute, to note this down. Now, what happens is, normally when we are doing the theory part of this, it may look very simple, but when the question comes, we might get puzzled. So that is why it is important for us to remember the simple things correctly. Then I trust you that you will remember this, so that when a complicated, so-called complicated question arrives, we don't make a mistake. I'll give you a minute to note this down. If you are done, please let me know. Everyone done?
Done, sir.
Okay, sir. Then the last of the basic gates, not last, I mean all the gates are basic, the NOT gate. This is the symbol of NOT gate. Now, what is the difference? The first difference is one input and one output. Do we see this?
Yes, sir. Only one output and one input only.
One output, one input. If the input is 0, the output is 1, so it reverses it, the reverse gate. If the input is 1, the output is 0, so we call it, the Boolean algebra becomes Y becomes A naught, or A ka complement. Do you understand this symbol, complement? The ulta of this. If the switch is on, input may, the output is off. If the switch is off, input may, the output is on, so it reverses it. This gate is known as the NOT gate. NOT. If it is 0, it becomes 1. If it is 1, it becomes 0. So if you have to inverse the result, we use the NOT gate. Three types of gates we have seen. The first one was the OR gate. Any one of them is on, the result is on. Boolean algebra was very simple. It was A plus B. The second one was AND. The Boolean expression was A multiplied by B. Both of them has to be on. The third is NOT, where we just take the inverse. Do you understand this?
Yes, sir.
These are the very simple gates. These are the basic gates, but what? But we are going to combine these gates, and then when the combination comes, and that is where the confusion may come. Don't get confused. The result is very simple. If you understand the basic logic, you can do any type of combination of gates that are there. And the first sort of combination that we are going to do is this one. And what is this one? The NAND gate. Now, what do you mean by the NAND gate? Anyone? It's a combination of
OR and NOT.
No, not and. It becomes NAND. Do we understand this? It is not and. Do we understand this, bacha?
Yes, sir.
Not and. Now, if you look very closely, and I probably will enhance this picture so that you get a better look at this picture, and then probably I will start to make more sense. So now let us look at this picture, and I hope you can see it on the big screen now. Now, if you see this part, this is the AND gate, yes or no? This is the
Yes,
AND
sir.
gate.
Yes,
And
sir.
this chota sa gola is your NOT gate. Do we understand this?
Yes, sir.
So this is a very slight difference between AND gate and a NAND gate. This chota sa gola makes the AND gate as the NAND gate. Will you remember this?
Yes, sir.
It also has two inputs, A and B, and it has a single output Y. Will you remember this?
Yes, sir.
And it becomes a NOT AND gate. NOT ka OT we have removed. Online teaching OT we have removed, and it becomes a NAND gate. Please draw this. Don't get confused with the symbols. If you get confused with the symbol, everything is lost.
Done, sir.
Then, sir, let us look at the Boolean expression of this. What will be the Boolean expression of this? It is a combination of NOT and AND. So if I look at Y, which is the output, it will be an output of AND. So it will be A dot B, but it is also NOT. So it will reverse this output. So this is how the Boolean expression looks like. Do we understand this? A dot B ka inverse, A dot B ka reverse, A dot B ka NOT. Do we understand this?
Yes, sir.
So its output will be ulta of A dot B. Its output will be the reverse of A dot B. And this is the truth table. 0 and 0. 0.0 karna padega. We'll have to first multiply 0 and 0. So you will get 0. But then you have to invert that 0. So you get 1. Do we understand this?
Yes, sir.
0.1 is 0. But you inverse it, you get 1. Do we understand the second result?
Understood, sir.
Similarly, the third one, 1.0 is 0, but you have to take the inverse. So 1.0 ka inverse becomes 1. When both of them are 1, the inverse becomes 0, and this becomes the truth table. Three things you have to understand here: the truth table, the Boolean expression, and the gate. Because anything, if you don't understand any of these, you are gone. I'll give you a minute to notice down. If you have any doubt, please raise them now. Take your time. Things might look very easy now, but you should not get confused, because a simple question like this will not come. They will put a lot of combination, maybe 2 or 3 gates together, and then they will ask you the question. So please don't get confused at that point in time. Otherwise, this entire class goes in vain. And I'm expecting at least one question from this logic gates. At least one question should come from this logic gates. I'm expecting that. And that is why we are spending so much time here, one class, so that we can understand it correctly.
Done, sir.
Done, sir?
Yes, sir.
Very good, sir. Then the next thing is your NOR gate. And now you would understand what does a NOR gate stand for. It will be a combination of do we understand this? It's a combination of
NOT gate and OR gate.
NOT and OR gate. This is your OR gate. This symbol is the NOT gate. So you combine and you get the NOR gate. Clear? It has 2 inputs, A and B. Only one output, Y. How does the Boolean expression look like? So first you will have to add this A plus B. And then you have to take the inverse of this. Do we understand this?
Yes, sir.
Looking at the truth table, 0 plus 0 is 0, but you take the reverse of it, so it becomes 1. 0 plus 1 is 1. Take the ulta of it, it is 0. 1 plus 0 is 0. 1 plus 0 is 1. The inverse of it is 0, so the answer is 0. 1 plus 1 is 1, but the inverse of it is 0. This is the truth table. Do we understand this? 3 things you have to understand here. Number 1, number 2, number 3. You make a mistake in any of these, and you are gone. I hope everyone is paying attention. NAND gate and a NOR gate. NAND, NOR, NAND, NOR, NAND, NOR. So now things might start to look a bit what? We'll see. Take your time, understand it. If any problem, discuss it right now, because else it will be too late. We're not going to come to logic gates ever again.
Understood, sir.
Done?
Done, sir.
Then we have the heading which is known as universal gates. Now, what do you mean by universal gates? A gate which can be used, gates which can be used to make anything, they become universal. Physics is universal. Maths is universal. Gates are also universal. If I visit alien civilization or alien civilization visits us, the laws of physics would be same. The value of the charge of an electron will be same for us or them. We can equate that values and we can see where the civilization stands and where we stand. Similarly, the NAND gate or the NOR gate is the universal building block of all digital circuits. So you might not use a AND gate, basic gate, NOT gate, or OR gate. You basically use NAND gate or NOR gate. Repeated use of NAND gates or NOR gates will give us other gates. Do we understand this?
Yes, sir.
We don't need AND gate, we don't need OR gate, we don't need NOT gate. We only need 2 gates, which are the universal gates, NAND and the NOR gate. Any digital system can be achieved entirely from NAND and the NOR gates. Do we understand this?
Yes, sir.
Yes, sir. No, sir. Then, sir, an example, sir. How do we get a NOT gate from a NAND gate? Now, the question is to get a NOT gate from a NAND gate. Now, how we have done this? How we have done this, and I'll just make it bigger so that you can see it better. The bigger is better. So I will just show it bigger together with the truth table so that we understand both of them. Okay, do we see this?
Yes, sir.
Yes, sir. The first problem is, what is the first problem? A NAND gate has two inputs, but a NOT gate has one input. Yes or no?
Yes, sir.
Now, how do we change that problem? How do we remove that problem? So what we have done here, you can look very closely. There is only one input. Yes, A. Do you see that input A? And then from that input A, we have made two connections. Do we see these two connections?
Sir.
So basically, the same connection, same input is put into two ways. So instead of having one input, we are having two inputs. But basically, in those two inputs, we are putting the same signal. Do you understand this?
Yes, sir.
That is how we make two inputs into one or one input into two. For a NOT gate, we only need one input. So what we have done, we have taken one input and broken up into two and then fed the two input into the NAND gate. Do you understand this?
Yes, sir.
So A is put in two positions and the result of a NOT gate, so remember result of a NOT gate is A ka complement. Yes or no?
Yes, sir.
And we will get that result. Now this entire symbol, it might look very complicated, but this is nothing but a NAND gate converted into a NOT gate. Do we understand this?
Yes, sir.
Now, let us understand the truth table so that things start to make sense. If I have A in one input, 0. A will be the other input as well, 0. So 0.0 is 0. But we will take the inverse of that because there is an inverse here. So the answer will be 1. So what we have done here is we have converted 0 into 1 using the NAND gate. So this NAND gate is now functioning as a NOT gate. Do we understand this?
Yes, sir.
Similarly, when I put A1 in the input, in one input, there is 1. The other input is also 1 because the other input is also same. 1.1 is 1, but the inverse of that is the NAND gate. So the answer is 0. So what do we get? We put 1 in the input, we get 0 in the output. So this NAND gate is now functioning as a NOT gate. Do we understand this?
Yes, sir.
That is why this NAND gate can be converted into a NOT gate. Can I have some raise hands from everyone that we understand this? This is where things start to get complicated.
Sir, once again repeat, sir.
Yes?
Repeat, sir, once again.
When the input is 1, both the inputs are 1. If the input is 0, both the inputs are 0. Do we understand this?
Diagram, sir. Diagram repeat, sir.
First, understand what I'm saying. When one input is 0, the other input is also 0. We understand this?
Yes, sir.
When one input is 1, the other input is also 1. We understand this?
Yes, sir.
How do I make same input? I just use one input and break it into two. And that is what we have done here. I have broken one input into two. I have broken one input into two. Now I have broken one input into two. Same input had been fed into two branches. So one has been put into two branches, and that is how the diagram look like. Do we see the diagram now? That is how the diagram look like. This A is the only input I have, but this A is given in 2 points, here 1 and here 2. So when I put 0 here, 0 comes here, 0 comes here. We understand this?
Yes, sir.
When I put 1 here, 1 comes here and 1 comes here. Do you understand this?
Yes, sir.
So with 1 input, I'm getting 2 inputs. Do you understand this now?
Yes, sir.
Any doubt? Do you understand the truth table, how I've converted it?
Yes, sir.
We understand this?
Yes, sir.
Any doubts?
No, sir.
Pakka?
हाँ sir, पक्का.
Okay. Please note it down. This is the conversion of a NAND gate into a NOT gate. NAND gate is converted into a NOT gate. Because as we go further ahead, the number of inputs, the number of gates will increase. If you don't get it correctly in the first gate, the answer is always going to come ulta. Do we understand this?
Understood, sir.
Have you written this down, sir? NAND gate, not gate from NAND gate. Have you written it down?
Yes, sir. Done, sir.
Then we come to the more difficult one. And the more difficult one is this one. We have to manufacture an AND gate from a NAND gate. We have to manufacture an AND gate from a NAND gate. Now, what's the difference between an AND gate and a NAND gate? The NAND gate will give the reverse of the AND gate. Yes or no?
Yes, sir.
So we have to reverse that reverse and make it into an AND gate. Do we understand this?
Yes,
The
sir.
NAND gate will give you the ulta of AND gate. So that ulta has to be made Sida again. The reverse has to be make the original thing again. So I will add a NAND gate with a NOT gate and I will get the result as the AND gate. Do we understand this?
Yes, sir.
I need some raised hands from everyone that we understand this. So I will have to put a NOT gate after an AND gate, and I will have to put a NOT gate after a NAND gate, and I will give an AND gate. Yes. So see, this is what I have done here. After a NAND gate, I have put a NOT gate, and I have got the result as the AND gate, and I will make it bigger to make sense to you that I have done the same thing here. We have done the same thing here. It's pure logic. Do we see this? Oops, where is it? Do we see this?
Yes, sir.
This one is a simple NAND gate, yes or no?
Yes, sir.
And just now we have seen how do we create a NOT gate from a NAND gate. This one is that, a NOT gate from a NAND gate, yes or no?
Yes, sir.
So I have created a NAND gate and I've added a NOT gate. The result would be an AND gate. Can we have some raised hands again from everyone that we have done this correctly? Okay. So remember these simple things. It's not about remembering. It's about just understanding what is being done. And now you can see the truth table as well. The truth table does not look very different. It looks like what it should be. First, I have a NAND gate. So 0.0 is 0. Ulta of that is 1. And then again, I do ulta of that, I get 0. 0.1 is 0. I do ulta, I get 1. I do ulta again, I get 0. 1.0 is again 0. Ulta of that is a NAND gate. That is 1. Ulta of that is 0. 1.1 is 1. Ulta of that is 0. Ulta of that is 1. Do we understand this? Raise hands.
Understood, sir.
I'll give you 1 minute to note this down. Whatever conversions are given in this book, in this series, remember that those same conversion, those same questions are going to come in the examination hall. So what we are doing here are questions. Do we understand this? We are not doing theory, we are doing questions. Do we understand this?
Yes, sir.
Ajal, speak. Do you understand that we are doing questions here?
Yes, sir.
Okay, sir. Shall we move ahead, sir?
Move away.
Shall we move ahead?
Yes, sir.
This is the next thing, the OR gate from the NAND gate. Now, this is how no one is going to ask you to create a OR gate from a NAND gate. That will not be the question. The question would be, they will give you this symbol and they will ask you what is the result. Do you understand how questions are framed? Do we understand how questions are framed? Yes, sir. No, sir.
Yes,
I don't hear you, sir. I speak loudly. Do you understand how questions are framed?
Yes, sir.
They will not ask you in your exam ki convert a OR gate into a NAND gate. No, they will not ask you that.
Okay.
Or convert a NAND gate into an OR gate. They'll ask you, they will give you this symbol. The symbol, you see this? You'll see you give this bada symbol and then they'll ask you what is the result. That's as simple as that. Okay. So now let us try to find out the truth table. And right now we'll only concentrate on that truth table. Right? Let us suppose that I put 0 here. If I put 0 here, what will I get here? Tell me. Let me make it bigger so that you can see it bigger and then probably you can make more sense. And if you don't understand the symbol, we are gone. That is why I had given you time, but if you have not utilized that time, we are gone. Okay. When I give 0 over there, what will I get on that other side?
1.
Because it is a NOT gate. We understand this?
Yes, sir.
I don't see raised hands. Pooja, are you there? Okay. So 0 gives me 1. This is a NOT gate. If I put 0 here, what do I get here?
1.
1. Now 1 and 1 here. And this is a NAND gate, yes or no?
Yes, sir.
So here I put A, here I get the complement of A. Here I put B, I get the complement of B. So now I get 1 and 1 here. Now when I put 1 and 1 in the NAND gate, 1 and 1 in the NAND gate, what do I get at the output? So what is the output here?
0.
0. Now look at the entire thing, entire picture. When I'm putting 0 here and 0 here, I'm getting 0 here. Do we understand this?
Yes, sir.
And that is the first result. If I put 0 here and 0 here, if I put 0 and 0 here, the end result is 0. Do we understand this?
Yes, sir.
And that is an OR gate. Yes or no? Both are 0, only then we can get 0. Yes or no?
Yes, sir.
I'll do one more with the blue ink. This is the blue ink. If I put 1 here, what do I get on this side? I will get 0. Yes or no?
Yes, sir.
If I put 0 here, I will get 0. I will get 1 here.
Yes, sir.
1 and 0. When I put in NAND gate, 1 and 0. When I put in the NAND gate, what would I get?
1.
I will get 1 here. Do we understand this?
Yes, sir.
So 1 and 0 put here. The answer is 1. Which gate does it represent now? It is an OR gate. Yes or no?
Yes, sir.
And that is how you can find out this truth table, and that is how truth tables are made. So they will ask you, if I put 0 here and 1 here, what is the output? And then you will have to use your head and tell me what is the output. Similarly, when I put 0 here and 1 here, I will again get 1 here. If I put 1 and 1 here, I will get 1 here. So this becomes an OR gate. They will not ask you to convert an OR gate into a NAND gate or a NAND gate into an OR gate. What they will ask you is
Symbol.
the answer of this truth table. Do you understand this?
Yes, sir.
I'll give you a minute to note it down. Can we move ahead in life, bacha?
Done, sir.
Done, sir. Then the next one, sir. And then we will do one more and then probably move on. A NOT gate from a NOR gate. This you understand is a NOR gate, yes or no?
Yes, sir.
Again, it needs two input. How do I produce two input? I only have one input here. I convert it into two. Do we understand this?
Yes, sir.
And when you will draw the truth table, you will understand that if I put 0 here, I will get 0 and 0 here. Yes or no?
Yes, sir.
And what will the result of 0 and 0 on the NOR gate?
1.
0 and 0 will become 0. 0 ka ulta will become 1. So I will
Input
get 1 here. Yes
one.
or no?
Yes, sir.
So when you put 0 in the input, you get 1 in the output, and hence you have converted a NOR gate into a NOT gate, or you have created a NOT gate out of a NOR gate. No one is going to ask you this. They are going to give you this symbol and they are going to ask you what is the result. Do we understand this?
Yes, sir.
Okay. The last one in this category, and I'll give you a minute before that. Or last two, or last one, and then we'll go into XOR gate probably. And remember all these conversions, because any one of those conversions will be coming as question in your exam. Then please don't become Gajnis and say that I don't remember it. Shall we move ahead?
Yes, sir.
This one, and this one tells us to convert a NOR gate into an AND gate. A NOR gate into an AND gate. If I put 0 here, I will get 1 here. Do we understand this?
Yes, sir.
If I put 0 here, I will get 1 here. Do you understand this?
Yes, sir.
Ulta, because this is a NOT gate. If I put 1 and 1 in a NOR gate, what will I get?
0.
0. So 0, 0 gets us 0. That we cannot say whether it's an AND gate or a NOT gate or a NOR gate. But if you use different combinations, you will find out this. But what you have to understand is when you give one input, what is the output? Do we understand how to get the output from the input?
Yes, sir.
That is all we need to understand here. Shall I move ahead?
Done, sir.
This is where we will, since this is different, so we will understand the XOR and the XOR gate. Might look a bit complicated, but shall we move ahead?
Yes, sir.
The exclusive OR gate is known as the XOR gate, and the symbol is also very fantastic. So this is the exclusive XOR gate. The logic symbol of the XOR gate is like this. You will have to remember this, beta. Will you remember this?
Yes, sir.
And you have to remember the Boolean algebra of the XOR gate. It is a bit complicated, but you'll have to remember is it is A dot B complement plus A complement dot B, and that will give you Y. Is it looking very complicated for you to remember this?
Sir, complicated.
But I can't help it. That is how a XOR gate looks like. I can't do it. I can't help it. But if you remember this Boolean expression, then I can help you. If you remember the Boolean expression, this is A dot B plus A complement dot B. If you remember this expression, then I can help you in finding out the result. Can you remember this expression now?
Yes, sir.
You'll have to remember this expression. Now, if you remember this expression, then I can tell you how to get the result. How will I find the result? Okay, if I put A as 0 and B as 0, both are zeros, what will be the result of the first expression?
1.
So, first I will have to make B ka complement. So, B ka complement is what? 1? Yes or no?
Yes, sir.
1 is to be multiplied by 0. So, 1, if it is multiplied by 0, the answer is 0.
0.
So, when I put 0 in both cases, I will get 0. Do you understand this?
Yes, sir.
0 plus. Again, I have put 0 here and I have put 0 here. Now, what is the result of this thing?
1.
0 here. 0 ka complement is 1.
1.
1 dot with 0 is also 0. So, this is 0 plus 0. And 0 plus 0 is 0. So, the answer will be 0. When I put both as 0, the answer is 0. Do we understand this? How I have converted this truth table?
Yes, sir.
Can I have some reason that we understand this? Now, let us see what happens if I make A as 0 and B as 1. So let me again write it with a different thing. Oops. Let me again write it as a different thing. A dot B ka complement plus A complement dot B. Now let me put A as 0 and B as 1. A as 0 and B as 1. Can you tell me the result of the first expression? First, we have to find the B ka complement. B ka complement is 0. Yes or no?
Yes, sir.
B is 1, so B ka complement is 0. 0 dot 0 is 0. So the first expression is 0. Yes or no?
Yes, sir.
Raise hands from everyone. Okay. Then we do the second expression. Here I have put 0. Here I have put 1. 0 ka complement is 1. Yes or no?
Yes, sir.
1 ka 1 is 1. 1 dot 1 is 1. So the expression of here, this expression gives us 1. Yes or no?
Yes, sir.
Now 1 plus 0 gives us what? 1.
1.
So y becomes 1. And this is the result of this red one. 0, 1 gives you 1. Do we understand this?
Yes, sir.
So you have to remember the Boolean expression. If you forget the Boolean expression, you are gone. You are gone if you have forgotten the Boolean expression. We understand this?
Yes, sir.
That is the exclusive OR gate or this OR gate. I'll give you a minute to note it down. The symbol first and the Boolean expression. If you understand the symbol and the Boolean expression, you should be good enough to solve any question that comes on this OR gate or the next one, the OR NOR gate, the XNOR gate. Have you finished your chit-chatting so that you can move ahead?
Yes, sir.
Okay. This is the exclusive XOR gate. Exclusive NOR gate, sorry. If you make it smaller. Exclusive NOR gate. And this is the symbol of this XNOR gate. The symbol looks exactly similar apart from one small symbol. Yes or no? Apart from this symbol, do we understand this?
Yes, sir.
And the Boolean expression is this entire thing. This is the Boolean expression. Do we understand this? Y is equal to A into B plus A complement into B complement. Do we understand this?
Yes, sir.
Okay. Shall I give you an example of how these results are obtained, or you will be able to tell me? If I put 0 for A and 0 for B, Can you tell me what will be the answer? 0 for A and 0 for B. Can you tell me what is the answer? Pooja is going to tell me the answer. No. Kajal is going to tell me the answer. 0 for A and 0 for B. Fatafat. First tell me, if I put both zeros here, what do I get in this yellow wala expression? What do I get in yellow wala expression? Pooja, Kajal, tell me. When I put 0 in both, what will I get? First expression, the yellow one.
0.
Yes, that is 0. Then you have to also tell me it is plus here. What will I get in the second expression? I will make it blue. What will I get? Oops. In the second expression, if I put both zeros here, the blue expression.
1.
Yes, 1. That is correct. And 0 plus 1 is how much? Now it is very simple.
1.
1. So this is the result that we get. Do we understand this, bacha?
Yes, sir.
Yes, sir. But that is all you need to understand, sir. I'll give you a minute, sir. If you don't remember the expression, bacha, you are gone. Do we understand this?
Yes, sir.
And then we'll quickly move on to this table, which is we have already understood. Have you understood this? Shall I move on?
Yes, sir.
Well done. Then you come to this laws of Boolean expression. A plus 0 is A. We understand this?
Yes, sir.
A plus 1 will be 1. A plus A will be equal to A. A dot 0 will be 0. A dot 1 will be A. A dot A will be A. A plus A complement. A dot A complement. A complement dot A double complement. You understand the symbol of this double complement? A का complement, उसका complement. Got it? Do we understand all these things?
Yes, sir.
Yes, sir. I'll give you a minute, sir, to see it, sir.
Sir, explain third expression of not.
Yes, beta.
Explain third of not.
There is nothing to explain here. You take A as anything. A is 0. So 0 plus A ka complement is 1. 0 plus 1 is 1. Correct? So you get 1. So A plus A complement is 1. Yes or no?
Yes, sir.
That's it. A dot A complement is 0. You take A as 0. 0 dot 1 is 0. So that is the result in the second case. Do you understand this?
Yes, sir.
A can be anything. A can be 1. A can be 0. So just put the values and see the answer. Okay?
Okay, sir.
Got it?
The third one. A double inverse dot A.
अरे use थोड़ा brain ना. A is 0. 0 का complement is 1. फिर से take complement.
One
So
complement
it
zero.
again becomes 0. Do you understand this?
Okay, sir. Okay, sir.
Double complement यार. A का complement का complement. So A का double complement becomes what? It becomes A only, no?
Yes, sir. Done, sir.
Done, sir. Well done, sir. Shall we move ahead, sir?
Yes, sir.
Yes. So this is a law, and I will not explain this law. You understand commutative law? A plus B is B plus A. Yes or no? A dot B is B dot A. Yes or no?
Yes, sir.
Associative law. A plus B plus C is A plus B plus C. We understand this? A dot B dot C is A dot B dot C. We understand this? Everyone understand this? Yes or no? अरे बोलो yes or no?
Yes, sir.
Ah. Then you have this distributive law. A dot B plus C is A dot B plus A dot C. We have seen this since third standard or fourth standard. Yes or no? A minute to write it. Oops, I've changed the screen. Sorry. A minute to write it. Fatafat do it. When you are written, Just raise your
sir.
hands that we are done. Yes? If we do not want to write so much, it is all in your sheet, you can just mark it. Then again, here are some useful theorems. The more you can remember, and I'm not going to explain these because we don't have time to explain all this. If you can remember these identities, it will be very good. If a very complicated question comes, you might need this. Okay? Yes or no?
Yes, sir.
So we'll not discuss this. So there is no point of discussing this, taking all these A and zeros and telling you that A को zero डालने पे और zero को डालने पे ये आने वाला है. It does not make any sense. Shall we move ahead?
Yes, sir.
De Morgan's theorem. Again, there is nothing to understand here. You put different values of A, you put different values of B, you will get this. So A plus B ka complement. You might have, you might not have read the set theory. This is from set theory, De Morgan set theory. A plus B ka complement is nothing but A complement dot B complement. Is set theory. Will you remember this? And
Yes,
A dot
sir.
B ka complement is A complement by B complement. Just remember this. Well, it will help you in probably solving a question which might come. The De Morgan's theorem. Can you remember this?
Yes, sir.
Pakka?
Yes, sir.
Good one, sir. Then, sir, here there is a summary of the logic gates given, and I am not going to get into that summary because we have already seen that summary. I'll just show you a screenshot, and you can see and understand it. This is the summary that I'm talking about. This entire summary is given to you. Yes or no?
Yes, sir.
This is your OR gate. We understand this.
Yes, sir.
A plus B is the answer. This is the truth table. We understand this.
Yes, sir.
And this is how the question comes. This is the battery. If any one switch is on, this lamp will be on. Yes or no?
Sir.
If A is on, current will go through A. If B is on, current will go through B. If A and B both are on, current will go through A and B both. The lamp will glow. But if both A and B are off, you will have a switched off lamp. Do we understand this?
Yes, sir.
So that is a OR gate in electrical circuit. Do we understand this?
Yes, sir.
And similarly, this diode, this is also an OR gate. When it is, how do we understand this? Can anyone tell me? I put two diodes. How do I make sense now? In the electrical analog, I was making sense, but how I'm making sense in this diagram? Tell me. How does this relate to this? 0 plus 0 shall give me 0. How do I get this? How do I get this? Tell me. If this is 0, it will not conduct, so it will be 0, yes or no?
Yes, sir.
If it is 0, it will not conduct, it will be 0, yes or no?
Yes, sir.
So 0 and 0 will become 0, yes or no?
0. Yes, sir.
Now we understand this. If it is 1, it will conduct, it will be 1, yes or no?
Yes, sir.
If it is 0, it will not conduct, it will be 0.
0.
1 plus 0 will be 1, yes or no? That's how we get it. Do we understand this?
Yes, sir.
So this is how a question might come. A diode wala question may not come because might just get too complicated. But do we understand this? Yes or no?
Yes, sir.
Okay. So there is a description given, and this is the description for the other gates. This is the description for the AND gate. The other one is the description for the NOT gate or the inverter gate. Do we understand this? When both of the switch is on, then only the lamp is on. We understand this?
Yes, sir.
That is the electrical analog. This is the NOT gate. If A is on, lamp is off. If A is off, lamp is on. Do we understand this?
Yes, sir.
This might not come because it gets too complicated. So the diode wala part may not come because it might look complicated. What can come is up till here, up till this column. Do you understand this?
Yes, sir.
Shall we move on to some questions and answers from the previous year so that we understand what we have understood?
Yes, sir.
Okay, sir. So let us move on to some questions. The number of questions are also very less here. So let us try to make some sense with the question. And you can see the number of questions and the quality of questions is very simple. And this is the first one in this category. Can you give me the answer for this one? In the Boolean algebra, y is equal to a plus b implies what? I'm waiting for your answers. Read the options carefully. 99.9% will give you -5. Only 100% gives you +4. Yes, bacha.
Option A, sir.
Option A is wrong. -5. See, if after doing so much, so complicated gates, you can't tell me what is A plus B, well, the entire hard work that we have done has gone down the drain and it is flushed, and right now it is in the municipal line going towards sewage. No one understands? You don't understand what is written? Can anyone read me the options, please?
B, sir.
B, sir. Why are you so sad about it, sir? Why are you not confident about it, sir? We will
B,
get
sir.
an output if any one of the input is on, yes or no. They've
Sir.
just put it in a different language. Yeah, this is English. Can't help it. This is simple English language. Do we understand this, everyone? Can I have some raised hand that we understand? This simple A plus B. A plus B is OR gate, yeah. A plus B is OR gate. If any one of them is on, the result is on. Please don't do, I will call stupidity like this, because this is a stupid answer that you have given me. And I can't appreciate stupidity. Because this stupidity has lost me 5 marks. And this 5 marks would have lost you your college. Whatever college you were aspiring for. You would have lost your college just for this stupidity. Can I expect more attentiveness in the next question? Yes or no?
Yes, sir.
Chalo, let's aim for aims. AFMC, do you know AFMC? Medical College in Pune. It's a very famous college. Now it's also on the NEET. Yes, which are the following gates represents to the truth table, and you can see there's come multiple times, and maybe it can come again in this year also. Every 3 years, 2 years, 1 year, they repeat. Which is this gate? Tell me. Tell me. Tell me. 0 and 0 gives 1. 0 and 1 also gives you 1. 1 and 0 also gives you 1. 1 and 1 gives you 0. Which is this gate we are talking about? Simple 4 gates are given.
NAND gate.
The option A, B, C, D, bolna.
A.
Option A is the correct one. Well done. So you have scored +4 in this, because you kept your whatever dhyan or concentration 100%, and this is what I expect, because with putting so much of energy and so much of hard work, if you get -5, this is a shame. And let's not be ashamed. Let's get to this one. I hope everyone understands this. Which of the following gates will have an output of 1? And if you don't understand symbols, you are gone, my dear friends. If you don't understand symbols, you are gone. Yes. Anyone with an answer? Shall I help you? This is one. Oops. This is one. This is one. What will be the output here?
0.
0. So this is definitely not the answer. A is not the answer. So these two options are gone. This is how you use your brain. Do we understand this?
Yes, sir. C and D. Option
Do you
C.
understand this? So now we have to find out whether B is there or not. If B is there, then this is the answer. If D is there, then this is the answer. Yes or no?
Yes, sir.
Just find out the answer of B, yaar, and you get the answer, yaar.
Option C, sir.
Option C, sir. This is how you use your brain, sir. Do you understand this, sir?
Yes, sir.
You don't have to solve the entire thing. You just use your brain and you get your answer. Do we have the confidence now to use your brain and how to use your brain and how to get the answer quickly, not solving all the 4 circuits?
Yes, sir.
Yes, sir. This is what some people call tricks, sir. I don't call it tricks, sir. I just call it using your common sense, sir. Nothing, sir. This one, sir, I think we have done this question, sir. Waiting for your answer, sir.
Option A.
Option A, this is an AND gate. How do you get the AND gate? This is the NAND gate and this is the NOT gate. This is the NOT of NAND gate, so it becomes the AND gate. Yes or no, sir?
Yes, sir.
Yes, this is how fast you should be, bacha. If you are not this fast, -5 is waiting and -5 gets you out of your college. This one, sir.
Option D, sir.
Correct, sir. This is the NAND gate, sir. One and one is giving you 0. The only case you can give 0 is a NAND gate. You all understand this? Yes or no?
Yes, sir.
If you remember the truth table, sir. If you remember the truth table, sir. If you remember the truth table, sir. And I repeat it, sir. If you remember the truth table, sir, use some logic, sir. 5 marks is waiting for you, sir. Let us see. Can you do this one, sir? Boolean algebra. And as you can see, let me see whether you can see or not. Question number 20 is what we are talking about. Pooja is sitting and talking with someone. I don't know who's that. She is not at all attentive. Now I can see your faces. Up till now, I was seeing only dark side of you. Now I can make out your faces as well. That is good. Chalo. Let's see who gives me this one. Who is sleeping? That are you not feeling well, bacha? That's why you are sleeping? Or the food was too much? Or you did not sleep at night? If you are feeling sleepy at 10 o'clock in the morning, that means something is definitely wrong with your system. And you must get yourself checked, beta, because this is the time when people get ill. My son was also ill. If there is something that is troubling you at 10 o'clock in the morning, something is wrong. You must get a checkup. Yes, question number 20, bacha. In the following circuit, the output Y for all possible inputs of A and B is expressed by the truth table. Which one? 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 So now, how will you do this question? Again, you have to use your brain. Now see, you put 0 here. You put 0 here. Depending on whether you get 0 or you get 1, you can eliminate 2 options. Do you understand this? That's how you have to work smarter. You don't have to do the entire thing. Do you understand this?
Yes, sir. Option in A and B.
Option? So let us put 0 here. Let us see. What is this gate? This is the NOT gate. Yes or no?
Yes, sir.
So 0 and 0 will give you what?
0, 1.
This is a not 0 and 0 will give you 1. Yes or no?
Yes, sir.
1 and 1 is put here. So what do we get here?
0.
So the option has to be between A and B. Yes or no?
Yes, sir.
Now you just see which option is different. Which option is different. So you can just use any of this. You can find out this or you can find out this. If you get 1, the answer is A. If you get 0, the answer is B. Do we understand this?
Yes, sir.
Now tell me what is the answer. Don't raise hands. Tell me the answer.
Option A, sir.
Option A, sir. And that is how you do things quickly, sir. You don't have to find out the entire truth table. Pooja, do you understand this? Don't have to do the entire truth table. Kajal understands this. Don't have to understand the entire truth table. You just have to do 2 things and you are done. And that is the reason I have discussed this question. I hope I am making some sense here. Am I making sense here?
Yes, sir.
Yes, so I will, we cannot do the entire question. Only one question is left. So we will do the second last one. And this is the last chance to redeem yourself. You are like cash vouchers. So you can redeem yourself at any point in time. Let's see if you can get the answer for this. To get an output 1 from the circuit, what should be the value of the inputs? Tan-tan-tan. Let's see. Who gives me this one? Only 100% attempt will give you +4, else everything is -1, -5. Remember, if you can't do a question of logic gates, you have done -5 or -4 if you have not attempted it. And again, I will tell you my trick of doing it. You can call it trick, you can call it use of the brain. But that is how I use brain. That is how everyone should use brains. Don't have to put all the values, remember that. Don't have to put all the values, remember that. You don't have to put all the values, remember that. You have to do 45 questions in an hour. If you put all the values, you will be wasting 2 or 3 minutes in this question, which is not worth it. Don't have to do the entire truth table. You don't have to do the entire truth table. You don't have to do the entire truth table. Anyone there?
The D.
23 card. Which one?
D for Delhi.
D for Delhi. That is correct. D for Delhi. D for Delhi. That is the answer. Now, how do you get it faster? Anyone can tell me how do I get it faster? Kajal will tell me. Yes, Kajal. How do I get it faster? Pooja is sitting so far ahead that I can't get the mic passed to her. So Kajal, tell me how do I get it? Kajal has no idea. She is smiling. Do you have idea, Kajal? Or you want to get idea or Vodafone? Both are same now idea, I think. No idea?
Yes, sir.
No idea?
Yes, sir.
Okay, I'll give you the idea. I need to get Y1 here. And remember that this is a AND gate. I can only get 1 in AND gate if I have 1 here and 1 here. Yes or no?
Yes, sir.
So that makes me understand that C has to be 1 here. Yes or no?
Yes, sir.
So these 2 options are gone. Yes or no?
Yes, sir.
I just check any one of the C and D. So I put 0 here and 0 here. 0 and 0. This is OR gate. This will give me 0. So this cannot be the option. So the only option is 1. See how quick I have done this. I have not taken even 5 seconds. Yes or no?
Yes, sir.
And that is how quick you have to do it. If you want to get into your dream college, this is how fast you have to be. And trust me, you can be faster than this because I am an older processor. My brain is deteriorating. I can't remember things. I am more like Ghazni. 5 minutes before what I speak, I don't remember. But if you can't be faster than me, you will be troubled. This one.
Option D.
Option D, NAND gate. Yes. So you understand the logic. See. Now this one. This is AIEEE. Can you give me this one? Because if it is come in AIEEE, it can definitely come in your AIBMT. Yes, this one.
Option D, sir.
D or B, bacha?
B.
No, it's not C, beta. See, beta, for a NOT gate, you need one input and one output. It has two input, bacha. So it can't be. Okay. Sorry. Sorry. What I said was illogical. Even I make mistakes. No, that is not the answer. That is not the answer. 24. Okay. How do I do it? I have to. What is this? What is this? This is a NAND gate, yes or no?
Yes, sir.
But when I put it like this, it becomes a NOT gate, yes or no? This is a NOT gate, right? NAND gate converted into a NOT gate, yes or no? So if I put 0 here, I will get 1 here, yes or no? If I put 0 here,
Yes,
I will get a
sir.
1 here. And 1 plus 1 will give me 0 here, correct?
Yes, sir.
So it cannot be a NOT gate, it is gone. Yes or no? It
Yes,
cannot
sir.
be a NAND gate. This is also gone, yes or no?
Yes, sir.
Then I put the red one, and then the red one will give me the answer. If I put 1 here and 0 here, I will get 0 here and 1 here,
Yes, sir.
and I will get 1 here. Yes or no?
Yes, sir.
1 plus 1 and 0 is giving me 1. What is the answer now? It has to be the OR gate. Yes or no?
Yes, sir.
And that is how you get the answers quickly. Now, to practice more on this, because you would be needing a lot of practice and the questions here are not enough for you to practice. You have variety of questions. Where? In the exercise just above it, level 1. Will you be solving these questions in level 1? Can I trust you on this? Today you will be going back home and you will be solving this entire exercise level 1. Yes or no?
Yes, sir.
Can I trust you? And you only
Yes, sir.
concentrate yourself on the question which has all these gates so that you can do them quickly and you can get out of them even quicker. Okay?
Okay, sir.
Chalo. And I'll wind up the class here. Practice a lot, and I can tell you that the question that you are going to get is going to be way simple. The question that we have done are way difficult. Okay,
sir.
but you cannot take much time into that, and you have to use all these small tricks that I have told you in this class. Any doubt, anyone? Please raise it now.
No, sir.
Then, sir, it's my duty, sir, to tell you that you do all the questions from the exercise. There are not many questions there. I can only see 37 questions in the exercise. These 37 questions, I think, can be done in 40 minutes. I'm giving you 3 minutes extra. I'm giving you 1 question per minute. And I'm giving 3 minutes extra. So take it as a test. Take it as what?
Test.
Take it as a test. Do you have any class now?
Yes, sir.
Yeah, so as soon as you finish with your class, after lunch, you sit at 2 o'clock or 3 o'clock or 4 o'clock, whatever time it is, take 40 minutes of your time and do this entire 37 questions. And if you can do them, you have done exceedingly well. Okay, will you
sir.
try it?
Okay, sir.
Chalo then, try it, and I'll see you in the next class tomorrow. And we will be, I think, doing AC in the next class. I'll send you the sheets. We'll be doing AC first, then we'll move on ahead. Because AC, I am sure that a question will come. So we'll do AC in the next class. Till then, have a good day. Take care. God bless you all.
Okay, sir. Bye.
Take care.